This is the screencast for section 4.4, example 7, calculating the ebb and flow of tides. Ebb and flow of tides is rising and lowering of tides. One particular July 4th in Galveston, Texas, high tide occurred at 9:36 a.m. Okay, so I'm going to call that the beginning right off the bat, and I'm going to say that high tide occurred at 9:36 a.m. So at time zero, let's see, it says at the time the water at the end of the 61st Street Pier was 2.7 meters deep. So at time zero, the height was 2.7 meters. Low tide occurred at 3:48 p.m. Way to make that easy on us. So that's out here, at which the water was only 2.1 meters deep. So this is here, and this is time, let's see, I'm not going to call that time 3:48. I'm going to call that 6 hours and 12 minutes later. So that would be 12 minutes is 1/5. So 6.2 hours later, the tide was 2.1 meters deep. So now I've got a maximum and I've got a minimum. I can create an equation and answer my questions. All right, so first of all, let's see. I'm going to start out with a cosine curve because I can see that there's a maximum on the y-axis just like the cosine curve has. So y equals the cosine of x. Now I'm going to adjust the amplitude here. The amplitude, let's see, goes from 2.1 to 2.7, so that's 0.6. It only has a height of 0.6. The wave has a height of 0.6. The amplitude is half that height, so I'm looking for 0.3 in front of my cosine of x curve. Now I need to adjust the period. This, I should read the rest of the problem too. Assume that the depth of the water is a sinusoidal function of time with a period of half a lunar day, 12 hours and 24 minutes. So the period should be 12 hours and 24 minutes. Okay, so let's see. 2 pi is the normal period times 1 over some number is going to be 12 hours, let's see, and 24 minutes, so that's 0.4 hours. So multiply both sides by b, divide by 2 pi, you know the drill. So now my curve is y equals 0.3 cosine of x times, let's see, pi over 6.2 x. But this goes from negative 0.3 to positive 0.3. I want to go from 2.1 to 2.7. To go from a minimum of negative 0.3 to a minimum of 2.1, I need to add 2.4. So here is my sinusoid that would make the tide at time 0, 9:36 a.m., a high tide, and then low tide 6.2 hours later at 2.1 meters deep. So question A asks, at what time on the 4th of July did the first low tide occur? Well, let's put this in my calculator so we can see this a little bit better. Now, in adjusting my window, the period of this whole tide thing is 12 hours and 24 minutes, so 12.4 hours. So I think I'm going to want my x max to go to, I'm going to cover a whole day here. So let's go negative 12.4 as my min, and then 12.4 as my max. So we're going to be looking a little bit at what happened before 9:36 in the morning. And then my y min, let's go with -1 just so I can have a frame of reference with the y-axis. And then my y max only needs to go up to 2.7, so I'm going to go up to 4. All right, so I can see the part that I'm referring to. Here's the maximum on the y-axis, so this is 9:36 a.m., and then this minimum occurs at 3:48 p.m. All right, so at what time on the 4th of July did the first low tide occur? So the first low tide occurred, let's see, back here, second calc. You know what? I don't even need to minimize this. If I know the period is 2 pi, This point here is at 9:36 a.m. This is 12 hours and 24 minutes later. So this is 12 hours and 24 minutes ahead of time. Right in the middle is 6 hours and 12 minutes earlier. So that's 6 hours and 12 minutes before 9:36 a.m. So that would be 3:24 a.m. Part B, what was the approximate depth of the water at 6 a.m. and 3 p.m. that day? Well, 6 a.m. is before 9 a.m. It's actually 3 hours and 36 minutes. So that'd be negative 3.6 hours. And then 3 p.m. is, let's see, 3 hours, 5 hours and 24 minutes. So that's 5.4 hours. So if I go to my calculator, I can find what happened, hit trace, and go to negative 3.6 hours. That would be 2.32 meters deep. And then at 5.4 hours, I get 2.12 meters deep. Part C, what was the first time on July 4th when the water was 2.4 meters deep? Oh, okay. So now I need to set in Y2 2.4 and find the first intersection of the day. So since I get negative 9.3 hours, 9 hours and, let's see, 3/10 of an hour is 9 hours and 18 minutes before 9:36. So you're actually talking about 12:18 a.m. The now try problem is number 75. Again, we're going to look at some ebb and flow tides on a particular Labor Day. So apparently we're not going to study 4th of July anymore, just Labor Day. The high tide in Southern California occurs at 7:12 a.m. So again, I'm going to start out my curve with a high tide at, we're going to call 7:12 a.m. times 0. At the time you measure the water at the end of the Santa Monica Pier to be 11 feet deep. So at time 0, we got 11 feet deep. That was high tide. At 1:24 p.m. is low tide. Okay, so this is 1:24 p.m. So that would be, let's see, 6 hours and 12 minutes later. So this is going to be 6.2 hours later. We've got a low tide, and that's only 7 feet. So that's up here. So at time 6.2, 6 hours and 12 minutes later, we've got 7 feet deep. So this is high tide, and then this is low tide. Now again, we're going to assume the depth of the water is a sinusoidal function of time with a period of 1/2 of a lunar day, which is about 12 hours and 24 minutes. Well, just like the last problem, that means my B value is going to be pi over 6.2, similar to the example. So far I've got y equals, we're going to use cosine of x again, and then times pi over 6.2x. And then, let's see, so this only has an amplitude of 1. We need an amplitude of, well, it goes from a minimum 7 to a maximum 11. So this is a wave height of 4. I need an amplitude of 2. So I'm going to make this y equals 2 times the cosine of pi over 6.2x. But now this will stretch from -2 to +2. I want to stretch from 7 to 11. So to go from a minimum of -2 to a minimum of 7, I'm going to add 9. So y equals 2 times the cosine of pi over 6.2x, and then a vertical shift up 9. All right, so let's put that in the calculator. Now in this case, I'm going to make the same x min and x max negative 12.4 hours and positive 12.4 hours, so I can cover a full lunar day around time 0, which I'm calling 7:12 in the morning. Then let's see, my y min in this case, my y min can still be -1, but my y max, I got to go all the way up to 11, so I'm going to go up to 15, I guess. Let's make it 12. Part A asks, at what time on that Labor Day does the first low tide occur? The first low tide on that Labor Day. let's see, so that's going to be here, which would be 6 hours and 12 minutes. So not a full period, but half a period before 12 a.m. 6 hours and 12 minutes beforehand. So that's going to be at 1 o'clock a.m. Part B asks, what was the approximate depth of the water at 4 a.m. and 9 p.m.? Well, 4 a.m. is going to be before 7:12 a.m. Specifically, that's going to be, let's see, 3 hours and 12 minutes before, which is negative 3.2 hours, 3 hours and 12 minutes ahead of time. 9 p.m. is going to be an hour and 48 minutes after, so an hour, 48 minutes, that's going to be 1.8 hours after. So I'm going to hit trace, and I'm going to find out what's going to happen at negative 3.2 hours. There we've got a height of 8.9 feet. And then at 1.8 hours, we've got a height of 10.22 feet. Part C, what is the first time on that Labor Day that the water is 9 feet deep? So I need to make Y2 9. I'm looking for a depth. I'm going to graph this. The first time that day, it's going to be right around here. So second calc intersect. But I get negative 9.3 hours. Well, there aren't 9 hours and 3 minutes before 7:12 a.m. is actually the previous day. So now I need to look at this next intersection to find the first time on Labor Day that the height was 9 feet. So that's going to be 3.1 hours before 7:12 a.m. So that's going to be 4:06 a.m.